Okay, this is your Unit 6 assignment key. The first question here, we have a guy wire helps to support a tower. One end of the wire is 25 meters from the base of the tower. The wire has this slope, 8/5. How high up the tower does the wire reach? So when we're looking at this, the thing we're trying to show, just trying to pull a graph up here for you, is this. Just going to zoom out a bit so you can see what's going on. Here's a wire. It's attached 25 meters away, so between 0 and -50. Here it is over at 25. How high up the tower does it reach? The slope of this line should be 8/5. If we were to graph this, 8/5 is our slope. The intercept is what we're looking to find, and we find the intercept when, the y-intercept when x equals 0. If we start at 25 meters away, and we know that our slope is 8/5, 8/5 is the slope, 25 meters is the run, it's how far away, and we're looking for our missing value up here. So our change in y, or we could call it the rise, we're looking for here. This is just a proportion. We solve it with cross multiplication. 25 times 8 is 200, divided by 5 is 40. So the rise should be 40 meters, which we can see. I'll just pull that graph back up for a moment here, or think I will. We can see that the y-intercept is at 40. Next question here. And remember, for a numerical response, you don't write in 40 meters, you just write in 40. Here, determine the x and the y-intercept of the graph for this equation. So in these two things, finding x-intercept and y-intercept, we can solve this a couple of ways. One of the ways is by graphing. If we do it by graphing, then I'll just hide what we had before, and I'll put in, this is 12x minus 3y plus 12. Got this ready. This line here has an intercept at -1 on the x-axis and an intercept at +4 on the y-axis. So graphing is an acceptable way to find this. And the other way is by, for the y-intercept, we want to set x to 0 and then solve for y. So that's 12 times 0 minus 3y plus 12 equals 0. 12 times 0 is just 0. I'm going to throw the y over there because I don't like it being negative. I get 12 equals 3y. I'm going to divide both sides by 3 so that I can cancel out that 3. And 12/3 is 4. So 4 is my y-intercept, which tells me this one or this one are good possibilities. This is the wrong answer. I've circled over here. And for the x-intercept, oops, I'm going to have to make this pen a little bit smaller. For the x-intercept, we do the same thing, only we change the letters around. We set the y equals 0, solve for x. So 12x minus 3 times 0 plus 12 is 0. 12x minus nothing plus 12 is 0. 12x is -12. And to get x, I need to divide both sides by 12. -12 by 12 is -1. So we're looking for an x-intercept at -1 and a y-intercept at +4. It looks like that's the correct answer there. And x-intercept -1, y-intercept +4. +4 for y-intercept. Oops, down here. -1 for x-intercept. It's good when your graph and your algebra match each other. Next, a line passing through these points, -1, 2, and -5, -2, has the equation ax plus by plus c is 0. When a is bigger than 0, so when a is positive, the value of a minus b plus c is. This is the hardest question on this assignment, I'm pretty sure. It's not that hard, though. So we know that we have these 2 points. We know that if we want to find the slope of a line running between those 2 points. That's rise over run. Rise is change in y value, so there's a y value and there's a y value. 2 minus -2, that's 4. And run is change in x values, so -1 minus -5. -1 minus -5, that's also -4. Positive 4, forgive me. So 4 over 4 is 1. The slope here is 1. In the form y equals mx plus b, I know m is 1. So I'll write that in there. So right now I know that my equation is y equals 1x plus b. I don't know what b is, but I do have 2 examples of what y could be and 2 examples of what x could be. So at one point on the graph, this point here, here's my y value, here's my x value. So when y is 2 and x is -1, I can plug those values in. 2 is -1 plus b, so what's b? Move the 1 over. 2 minus -1 is 2 plus 1, that's 3. So b is 3. The equation of this graph is y equals 1x plus 3, or just y equals x plus 3. It wants it in general form, though. So if we're starting with y equals x plus 3, and I want to put it in that general form, I'm going to throw the y over there. So I get a 0 on one side. Well, I'll put the y in there. The y becomes negative. 3 sticks around. X minus y plus 3. This a on x, my coefficient of x is a 1. That's 1x. The coefficient of b is -1. That's -1y. The coefficient of 3, there is no coefficient, it's just a constant, is 3. So a is 1, b is -1, c is 3. If I take a minus b plus c, 1 minus -1 plus 3, that's 5. So this one here, the question itself is not super hard. The way that they've asked you to show the work is in this first find the equation, then change to general form, then once you have your coefficients, throw it into here, just piling on the opportunities to make a mistake. But 5 is what we're looking for here. Next question. What's the value of p such that a line passing through 6, 2, and 9p has a slope of -1? So we know slope is rise over run, change in y over change in x. The change in the y values is 2 minus p. The change in the x values is 6 minus 9. So 2 minus p over 6 minus 9 is 2 minus p over -3. 6 minus 9 is -3. I know that the slope is given to me. It's -1. So if that represents the slope and -1 represents the slope, they're equal to each other. I can set them as an equation. Once I've got that, -1, the slope, is equal to 2 minus p over -3, also the slope. Then I can fiddle around until I get that p. Multiply both sides by -3 to pull it out of the bottom of the fraction. -3 over there, -3 over there. These guys cancel. -3 times -1 is +3. 2 minus p is left over on the right side. I want the p, but I want it positive, so I'm going to throw the p on the left and the 3 on the right. Positive p is equal to 2 minus 3, and 2 minus 3 is -1. Next, if the ordered pair k, -5 lies on this graph, what's the value of k? They give us the equation 3x minus 2y equals -2. The x value is k, so the x value here is k. And we want to find it. The y value is -5, so they tell us what the y value is, -5, so we can evaluate, we can throw it in there. When we do that, we can say 3k is equal to -2y, when we know y, or sorry, minus 2y is equal to -2. I can take 2 times -5, that's -10, subtract -10, that's adding 10. 3k plus 10 is -2, move that 10 over there. 3k is -2 minus 10. 3k is -12. Divide both sides by 3. That's a 3. 3k over 3, cancel, cancel. K is equal to negative 12 over 3, which is negative 4. For all of these ones, we can also take a look at the graph of them to see, are we on the graph? Plotting them on a graph is a really good way to check your work. Here we've got, for this line, 2x minus 3y plus 12 is 0. Which of the following is true? So we can check. We can test this out. We can test it in two easy ways. Well, one more easy, the other one less easy, but still both possible. One of them is to take this initial equation, 2x minus 3y plus 12 is 0, graph it out, and graph what they show us. So the first one, y is equal to 2x plus 12. If I graph that, it's not the same line. It appears in a different spot. It has a different slope. Same x-intercept, different y-intercept though. F of x, which is the same as y, is equal to 3/2 x plus 6. If I plot that, that one has a different x and y-intercept and a different slope. The only thing it has in common is that it's a line with a positive slope. C says the slope is 3 over 2 and the x-intercept is 4. That's this. Is that this? I forget what I plotted. I plotted a million things here. The x-intercept is 4. Well, if the x-intercept is 4, I didn't plot that one out. I plotted the other one twice. If the x-intercept was 4, the x-intercept would be over here and the y-intercept up there. We would end up with a, well, the y-intercept would move too. We would end up with a line that is also, I'm going to sort of try to trace it over here. I don't know if you can see my mouse in this recording, but it would be a line that runs lower down with a positive slope. It's not the same line though. And our last one, the slope is 2/3, and the y-intercept is 4. If the slope is 2/3, that's m in our mx plus b. And the y-intercept is 4, that's our b. And this one lies directly over top of that spot. So this is the one that's true. We can also check it by just rearranging the equation to find the right form, the y equals mx plus b form. So if we rearrange for general form to y equals mx plus b form, then the slope is 2/3 and the y-intercept is 4, and those two criteria are both met for D. Next, determine the slope of the line that passes through these 2 points. Again, we could look at this on a graph. I'll just get rid of these 2 lines. Here, the points G and H, I've plotted here. If we're looking for the slope of a line that goes through there, a line that goes through both of those points is this one, negative 2x plus 3. The slope is negative 2. The y-intercept is 3. We can see that it works if we draw it out. Or we can take a look at our slope formula, rise over run, change in y over change in x. Change in y is negative 3 minus 15, and change in x is 3 minus negative 6. We get negative 18 over 9, which is negative 2. So we can show it algebraically or we can show it graphically, as long as we show it. Next, match the graph on the diagram with the equations below. So we're trying to match different versions of the same thing. Okay, so we have x plus y minus 2 equals 0, 2x minus 4 equals 0, and 2 other equations there. I think, where have I put them? Not there. There? I have. Good. So the first one, x plus y minus 2 is 0. That gives us a line with a negative slope. Out of these choices here, this is the one with the negative slope, the only one. So that's graph 2. Next, 2x minus 4 is 0. 2x minus 4 is 0, gives us a vertical line. So a vertical line is graph number 3. Next to y minus 4 is 0. To y minus 4 right here. This gives us a horizontal line. So the horizontal line is that one. That's graph number 1. And the other one better be graph 4, which has a positive slope. X minus y minus 2 is 0. If we try it out, x minus y minus 2 is 0, gives us a positive slope just below the origin there. Zoom in a little bit. Positive slope just below the origin. That's a good match. So it's graph number 4. So equation A is 2, B is 3, C is 1, and D is 4. Last one in this video, and then I'll move on to a different video because this is already 15 minutes long. Which of the following is not on this graph? We just need to test it. They give us all the x's and they give us all the y's. So if we have this equation, and I'm sorry that it showed up here twice. It's the same equation, just twice in a row. I don't know. Y is equal to negative 7/2 x minus 4. We just plug in the values of x and plug in the values of y, see if it works. So the y value, 0, negative 4, negative 39, 3, we just leave them in the y spot. And the x values, we plug into the x spot. I tried to color code it here for you. And we just test. In the first one, the left side is 0, the right side is 10. That's not right. In the other 3, the left and the right side are equal to each other when we test it out. So the one that's not on that graph is the one where the left side does not equal the right side. Okay, I'll stop this video, make some more for the rest of the questions.